Hey everybody, it's First Warning Storm Team Chief Meteorologist Brad Penovich. Hope you're having a great Wednesday. Today's topic is going to be brought to you by Chris Mulcahy, and it's convection currents. They're just not for cooking. All right, that's a bad weather joke, but convection currents are something we use for cooking, but they are really cool, and they happen in a lot of mediums, just not the atmosphere, just not your oven, also deep in the Earth's crust. And today, Chris Mulcahy is going to explore the topic of convection currents. It is really cool. It explains a lot of things that happen with weather in the atmosphere, specifically wind. A day like today would be a good example of that wind starting to pick up. So, with no further ado, let's go to meteorologist Chris Mulcahy. A lot of C's there, a lot of C's alliteration there. Chris Mulcahy, meteorologist, has your convection currents and weather school for Wednesday, May 6th.
Convection currents. It sounds complicated, but at the end of this lesson, it's going to be easy for you. It happens in the world around us, starting in the Earth's crust, in our oceans, in our atmosphere, causing wind, thunderstorms, and even clouds. Even in your own home, a lava lamp is a convection current, and a pot of boiling water is also a convection current. I'm meteorologist Chris Mulcahy, and this lesson of Weather School is everything about convection currents. Through this lesson, you're going to hear the words convection and current a bunch, so you probably should know what they mean. Convection simply is going to be a heat transfer by a movement of a liquid or a gas. Now, this transfer of energy has to only happen in a liquid or a gas. So, example number one, a pot of boiling water. So what's happening is there's always going to be that heat source. So that's going to be the stovetop. Picture this like the atmosphere, that when the sun is heating up the surface, that heat rises. Just like the warm air is rising in this pot of boiling water. It rises up to the top of the water. It spreads out and eventually cools back down. Where convection is also going to be the mixing of that fluid or that air in an atmospheric viewpoint. But as soon as that rises and falls, water starts to boil once all that water has mixed up to a certain temperature, or 212 degrees Fahrenheit. But I actually need this for demonstration number 2. Here's demonstration number 2. For this, we have some boiling water. We have 3 coffee mugs that are the same. I have this tub that I've filled with lukewarm water or room temperature water. And then lastly, I have these big things. These are pipettes. Most likely you don't have these hanging around your house, but you're gonna see why I need these. And also you need some red and some blue food coloring. So let's start this off right. Let's get the red food coloring. So what I'm going to do, I'm gonna take the pipette and we're going to illustrate with this experiment rising warm air and how the cold air is going to be replacing it. Or in this case, rising warm water replaced by colder water. So check this out. Get that out. Let's get the air out. There we go. We put this one in the middle. Squeeze it right there. So that's going to illustrate our warm water. Number 2, we'll get our blues. Feels like a legitimate experiment, right? Put it down. Do it again. All right, now we get to watch with everything happening. Lastly, pour some boiling water in this coffee mug, mug number 3. Put it underneath, and let's see what happens. This is absolutely mesmerizing, and I understand if you're just zoned out watching the different changes of the colors, but there's a lot of science here, and it's actually pretty cool. So convection, simply put, is the red right there. That's convection. Convection is just the pocket of rising air or water in this case that moves to a cooler area. And then once you get the current going, that is that convection current. So what's happening is you have all that heat moving to one place, but it doesn't just leave an empty spot behind. More water needs to take its place. Now, the earth, weather, always needs to be in what's called an equilibrium. So that's a balance. So that's why that colder air, or that colder water in this case, is moving back in. But then that hot water eventually reaches the top because more and more of that warm water underneath it is driving it upwards. But then in the meantime, that cooler water, which is a lot more dense, sinks back down, and it continues to repeat itself. And as I showed you at the beginning, this is very much what happens in boiling water. These big ovals that are forming from the change of that warm rising moist air to the cooling dry air that happens in the atmosphere, that's a convection current. And what's really interesting, that's exactly what happens in thunderstorms. So let's take that example and learn a little bit more about thunderstorms. What you're looking at right now, this is a classic supercell thunderstorm, or just a thunderstorm in general, as we're going to be focusing on the upper parts of this. So that water line that I was showing you, notice how the warm water had to spread out on the top? Well, the reason for that is because it can't go any further, but the same thing happens in the atmosphere. There's something called the tropopause. The tropopause divides the two lower layers of the atmosphere between the troposphere, where all of our weather happens, and the stratosphere. So it's at this point that rising moist air can't go any further. The only way it can is what's called an overshooting top. That is that updraft, as we've learned in previous weather schools, keeps on driving so fast that it's able to just get past the line before it stops. Meanwhile, everything else spreads out on the top. So if you've ever seen a thunderstorm with an anvil, the whole reason why is because of the density differences, and it can't go any further. And our experiment that we were just doing shows just that. But the same thing happens in a thunderstorm. Once that warm, moist air rises up, eventually it has to come back down. In other cases that could come down is wind and rain. But all in all, it's a convection current. And did you know, thunderstorms are also known as convective storms because they form from rising moist air, which is less dense than its surroundings. If we think bigger, there's another convection current that happens along our shorelines. It's called a sea breeze. What happens is the warm sun warms up the air and that rises. That's the convection. But eventually it moves towards the cooler air, which is over the ocean or a lake. That is going to allow for it to cool, eventually drop as it descends, and then it moves back towards the warmer air. It's a constant current that happens. And a lot of times through this, you can even form some rain showers and even some thunderstorms right along the coast. Briefly, this also happens on a global scale. Across the earth, the convection currents can create what's called trade winds or global winds that will steer ships and even steer hurricanes. Moving to our oceans, convection currents, the same thing happens. That warmer water is replaced by colder water, and this creates currents across the earth. And some animals even cruise along these currents to get from place to place. Another example, something you wouldn't think about, right beneath our feet, under the Earth's crust, is what's called the mantle. The mantle is just moving streams of molten rock that moves very, very slowly. This is what drives plate tectonics. Another couple examples just around the home, a lava lamp. Now, you might not know what a lava lamp is, but they were really big in the 60s and 70s. I even had one when I was growing up. But this is simple convection, a convection current. You need the heat source. That light bulb is heating the material that is in the lava lamp. It rises up. Eventually, once it gets to the top of the lamp, it cools and it drops back down. And it continues over and over and over again in a current. And when we're looking at convection, it's also around a campfire. When you see that rising smoke from the fire, that is also convection. But what keeps us warm, to complicate things, isn't necessarily convection, but thermal radiation. That is just that heat that is just being dispersed from the fire. That's why if you have your face turned, only one side of your face gets hot compared to the cooler side, because it's the direct radiation from the fire that's hitting you around it. Well, there you have it. Our experiment is now just a sea of purple, because in essence, convection is just the mixing of air or a mixing of a fluid. So just like in the atmosphere, that up, down, around, those ovals, after they go on for a while, air is going to be the same temperature. In this case, the water is the same color. So when you go out and about, you realize that convection currents are in the world around you, in a campfire, in a pot of boiling water, and in our everyday weather. Again, I'm meteorologist Chris Mulcahy. Hopefully you enjoyed this episode of Weather School, and I look forward to seeing you next time.
Thanks, Chris. Yeah, I love convection currents. It's one of the cool things. And when you see it happen in a thunderstorm, that's why time lapses of thunderstorms are so mesmerizing because you can actually see the convection in the clouds. And that's what causes a lot of movement. And sometimes what people confuse for rotation in the storm is just the convection current. Remember, rotation horizontally is what creates tornadoes. Up and down motion is typical in every single thunderstorm. So we would expect to see that, especially the up and down motion of roll clouds and shelf clouds. So today's weather school, I love it. Convection currents. It's going to get a little chilly, so we don't have as much convection though today. We're going to see a couple pop-up convective showers as well as that cold air moves in aloft. Coming up tomorrow at 1 o'clock, we'll have weather school again. Make sure you tune back in. And as always, if you miss any weather school, go to WCNC.com or YouTube and search for WCNC. We've got a whole playlist with all of our past episodes, which are now over 2 months of episodes. Pretty amazing. So go check it out. We'd love to have you check them out and see them again and share them with all your friends as we'll continue to do Weather School every day, Monday through Friday, at least at 1 o'clock on Weather School. Have a great, great Wednesday.